Hello, so we are back, and this time we have a nice laptop to repair. This is a HP laptop, Elite Book i7 Gen, HP Elite Dragonfly. This laptop is coming from a computer business and is saying not turning on. Let's test it. The power button is here. Pressing the power button, nothing happened. Let's plug a charger. We have only USB-Cs. These laptops, they have a common issue with the PD controller. So plug in the charger and the in the meter it is coming on. And it's working, 19 volts. I mean, the PD controller is negotiating the voltage, you can see. That's why we have 19. The other port, we have 19. So it's not like a PD controller issue. Pressing the power button, and nothing happened. I mean, the current is not going up, it's not doing anything. I will say, let's open the laptop and let's have a look. But these are good news. I mean, whatever it is, we can fix it, or we can go around the fault. I mean, when you're dealing with the USB-C, all what matters is actually you have a PD controller which you are not really concerned about if it's outputting 19 volts to the main power rail. But the important part is the chip is negotiating and you have 19 volts at the charging port. And from there you can come with a wire to the main power rail, and that's all. Same like we are doing on the Lenovo laptops. And also, a working PD controller is telling me actually the EC chip is up and running, the LDO is present, and the laptop is open. Okay, this is a nice, small, sexy motherboard. We have some marks here. We're not sure if it's liquid. Probably it's not liquid damage. Someone touched it. Yeah, probably. We have a BIOS chip here. Not sure if anyone tried to reset the BIOS actually, disconnect the battery. I mean, I know the job is coming from a computer business, but what they are saying, trust but check. So we disconnect the battery, we reconnect the battery, we don't have another BIOS battery here. Plug in the charger. I mean, I should see some charging current, but I can't see charging current. Check there. So actually the laptop is not charging. It's not charging also, apart from the fact it's not coming on. So pressing the power button, and nothing happened. The current is not going up, you can see, and I'm pressing the power button. Okay, let's check the main power rail. So the main power rail, which is here, is 0. Huh? I'm checking wrong here. 0. So the main power rail is not present. Which is strange because the LDO, it is present. We have a working EC chip. Weird, right? So this power supply is the power supply which is creating the main power rail and also is charging the battery. On the battery we have 0 volts. Let's try to bring the battery up a little bit, just to be sure there's no some glitch. The battery is 0 volts and it's not charging, it's not providing the main power rail and all that kind of stuff. Good. Now charging the battery, and the battery is taking like 2 amps, so the battery is charging fine. It's charging with 2 amps. Check that. The fan is spinning, so probably the laptop it is coming on. Okay, but it's taking no current from the USB. You can see that. No, nothing. I will say, let's try to figure it out what we have here. Check here, the fan is spinning. And you think the laptop is coming on? Probably. I mean, we reset the BIOS, so we have to wait a little bit. But yeah, the fan is spinning. We have picture. That's crazy. I mean, the laptop is still dead. Don't get me wrong, yeah? It's taking no current from the charger. But yeah, it's working on the battery power because we push some current into the battery. So we switched off the laptop. Let's go under the microscope and try to see what we're doing. We're fixing like original or we are going around the fault. And to be honest, it's more fun to going around the fault because, the way how the manufacturer designed it, it's already dead. I mean, no point fixing, a faulty design. So, what we are looking here, we have the USB-C. Then we have this big power supply, which is creating the main power rail. So what do we have here? This is a single MOSFET, which is strange to see single MOSFETs on such a small motherboard. Here we have another single MOSFET. So where are the other MOSFETs? Because we have a bridge. Can be this one and this one. Yeah, I think, yeah. Okay, let's plug the charger and check the voltage. Wait, actually the charger is plugged. Now, checking the voltage, we have to find the input. And here we have 0. Then here we have 19.9. Check on the screen, 19.9. Okay. Yeah, that's bad. We cannot go around, so we have to make this power supply to be working because this is providing the a custom main power rail. So the main power rail is not 19. The main power rail is actually the battery voltage, and also is charging the battery. So yeah, we have to fix that. Disconnecting the battery. Let's check the MOSFET. Yeah. So we know the power is coming till here. So this MOSFET, of course, is good. The gate is okay. This MOSFET is good. This one is good. This one is good. I mean, every MOSFET is good. Kind of sucks. Okay, the next step, we are looking for the driver. Actually, let me check the gates also. This one is fine. Fine. And fine. We have to find the driver of these 4 MOSFETs. But this is quite a nice motherboard. Check here. So actually the CPU has monolithic drivers. Yeah, those are very good. Not sure how much the laptop cost, but it's a good design. Now, where is the driver of this power supply? You think it's on the other side of the board? Yeah, probably. Probably because it's not here. If it's not here, it must be on the other side of the board. And we have to take the board out. Yeah, no easy pizza. No, because we have to take the motherboard out. Just give me like few minutes and let me take the board out. Now, just a parallel with that Lenovo. Remember the Lenovo with the failing MOSFETs? Yeah. But the Lenovo doesn't have 19 volts at the input on the power supply which is creating the main power rail. So it's not the same problem. Here we have 19 volts at the input of this power supply. So it's not the same. So basically, yeah, non-dodgy repair, we have to fix it properly, this one, in order to work, of course. I mean, you can easily strap 19 volts at the output, but it will not charge the battery. So it will work. You'll have 19 volts on the main power rail. The laptop, it will work, but it will not charge. And the motherboard is out. It's looking good. I can't see liquid damage. But where is the driver? If the coil is here, then the driver must be that one. Let's check under the microscope. And indeed, that's the one. You can see it's a ISL chip, interseal. Yeah, so this is the driver. Before replacing the chip, we have to do a few checks, yeah? Ooh, check here, we have a bunch of, how it's called, polyfuses, yeah? But that's not our issue. Our issue is actually this chip. So plug in the charger. And yeah, still it's taking no current. Now we can check a few things on this chip. The first, the input voltage, and probably is coming here. And the input voltage is 0 volts. Okay, that's interesting. Here is 0, 0, 19. Wait, what is this? So here you have nothing. And here we have 19. And now you'll jump and you'll say, yeah, it's a bar resistor. Yeah, no. No, it's not working like that. That resistor most likely is burned because the chip is gone. Because the chip is shorted. Otherwise, how a resistor can die? You know what I mean? So coming with current here and it's taking with 1.4 volts, it's taking 100 milliamps. Now I have a current limit. Wait a second. 120 milliamps with 1.4 volts. So let's bring the thermal camera. Let's try to find out what is shorted. Okay, so we have the thermal camera. Again, coming with current here. Huh? It's taking 120 milliamps, but what is getting hot? Nothing. Okay, let's raise the voltage. .1 amp. Check that. We are doing some dodgy thing. No, because we checked and it was 19 volts on the other side of the resistor. I mean, I was asking myself, maybe the power is coming here. Let's plug the charger and check one more time, just to be sure we are not pushing current, on things which are not supposed to have current. So one more time, here you have 19, here you have nothing. Like we have like 1 volt. Here we have 1.7. Yeah. No, we are good. Actually, we are doing the right thing. And the track is coming here and it's coming to the chip. Good, then let's push a lot of current. So pushing a lot of current on this resistor is taking 200 milliamps, and what is getting hot? I mean, we can see on the thermal camera is the chip. No, I can't figure it out. Let me come with alcohol because can be the capacitor. So it's the capacitor or the chip. No way. Check that. You see the capacitor? You can see it's getting evaporated, the alcohol from the capacitor. Huh? Is the capacitor? Is the capacitor. You can see the alcohol moving around the capacitor. Okay, let's raise the voltage. Yeah, it's the capacitor. You can see the crack exactly here. Yeah. Ah, can't believe. Can't believe dodgy capacitor. So basically this is the only capacitor here after the resistor. So in order for this RC filter to work, you need a capacitor. Good. Let's check for short again. I mean, yeah, we didn't check with the multimeter for short. But no, it's not short. No, we are fine. Let me grab another capacitor. Just to understand, you cannot take a capacitor from any place. So this is the back of the CPU. So most likely those capacitors are, working with 1 volt, 1.5. You can take the capacitor you want to replace. So we are replacing a capacitor which is connected to 19 volts with another capacitor which is connected to 19 volts. Yeah, we found here a bunch of capacitors, same size. Can you not replace the capacitor? Yeah, of course you can. So we are shorting the resistor, and yeah, we are fine. But resistor and capacitor, it will bring some delay for that chip. Delay, it's also a, interference filter. So overall, in this specific case, the capacitor is a good thing here. And the capacitor is soldered. Good. Let me cool down the motherboard. And we can test it. Yeah, definitely. Let's plug a charger. Ha! Check that, we have light. And the board is starting. Check that, it's taking current. It's trying to start. You can see? Yeah. So what voltage do we have now? We don't, because we didn't replace the capacitor. Wait a second. Wait a second. But the resistor was burned. We replaced the capacitor, but not the resistor. So here we have 19 volts. Lol. How? I think this resistor was getting hot, and that's all, because we have 19 volts, 19.4. And obviously on the capacitor we have 19.4. So this resistor is not burned. But what is the resistance of that resistor? 100 ohms? 10 ohms? 100 ohms. Okay. So 100 ohms resistor, it will not get burned if it's shorted to ground. I mean, you can calculate the current going through. But yeah, no. It's everything is fine. So if we are connecting the battery, just to give you an example before we are putting the motherboard back, just to do a few checks, yeah? So plug in the meter, and we can check the main power rail. Yeah, it's taking current, check that. So the main power rail, like we checked before, it was on this capacitor. Check on the screen, we have like 6.9, which is the battery voltage, right? 6.9. So I'm expecting this to push more current, but I believe the battery probably is too low, and this is like a pre-charge current. Let's push some current into the battery. Just a little bit of current, not too much. So pushing the current into the battery is taking 1.8 amps, but it's still not taking current from the meter. Why is not charging? Yeah, the CPU is on. Lol. So actually the board is on, but why is not taking current? Can be because the BIOS was reset and the board it will restart a few times. That can be a reason. Let me check one more time. This 270 milliamps is going. So here we have 7.4. I'm plugging the charger and we have 7.1, 6.1. Okay, so the power supply just creating on my main power LED is working. This power supply does not have a stable output voltage. So the output voltage is basically on whatever current is set up to push into the battery. A little bit more complicated to explain exactly how this is working, but we're gonna do that on a video. But still, why is taking only 260 milliamps? You think I can be wrong and actually that resistor is not a 100 ohms resistor? I mean, it's saying 100 on it. No way. No way. No, 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 no. So that resistor is dodgy. So if I check that resistor, it's showing me what? 100 ohms? But when the chip starts taking current, it show me nothing. Now it's not showing me as 100 ohms. The resistor is burned. I'm assuming it's 10 ohms. That's what I'm assuming. Yeah, our resistor is dodgy. I mean, it's 10 and 0 means how many zeros? 0. 100. I mean, 100 is 100 ohms. Or is 10 and the last number is the numbers of 0. In that case, is 10 ohms, which I believe is 10 ohms one. So I'm gonna take a resistor from here. Yeah, 4.7 ohms. What do you think about 4.7? Everyone will be happy with 4.7? Yeah. 4.7 ohms resistor. And we're gonna solder the resistor here. What did you say that the size is this one is smaller? Yeah, but the size doesn't matter, right? And the resistor is back in place. Fantastic. So what do you think? It will work now? Let's see. So connecting the battery. Wow, this is proper hot. Connecting the battery. Plug in the charger. 600, 800. It's a different story. You can see it's taking 800 milliamps, which I'm not happy with 800 milliamps, but it's still better compared with the last time. Okay, the current is going up 1.3, 1.4, 5. Yeah, it's fine. And the board is restarting. Yeah, I'm pretty sure it's good. And the current is still going up. Check that 1.7, 8, 2 amps. Working great. Let me quickly put the board back. Just give me like a few minutes. It was a hard repair? No, not really. It's not an easy pizza. Actually, there are two pizzas on this repair, two large pizzas. So two large pizza is still good. Right now, I'm working on the tutorials, like shortcuts, like how you can learn quickly laptop repairs, and I'm gonna explain there how this power supply is working. Okay, everything is back in place. Let's plug the battery. Battery is plugged. I think this one was here. Good. Plug in the charger. Let's see what it's doing. Anyway, it is coming on. Looks like it's pushing current. We need to wait. We have the light here. We need to wait because, okay, the BIOS is reset. And it's working fine. Check that. Huh? And it's taking 2 amps, exactly 2 amps. And it's loading the Windows. So what do you think about this? We have the charging light there. Not sure if you can see it there. And it's taking exactly 2 amps, which is 40 watts. And the Windows is loaded. And we have the charging sign, everything is fine. Yeah, probably the laptop has been reset. So one more time, it's taking 2 amps there. Unplugging the charger and it's still on. Everything is fine. Cool? Let me shut down the laptop. Update and shut down. Yeah, let's do it. So when you have a fault like this, you have a lot of flexibility. You can replace the capacitor or not. Yeah, you can short that resistor or not, or you can use different values of the resistor or the capacitor. Don't be that rigid when you deal with things which they are connected to the main power rail. It's always a wiggle. Cool? So I'm gonna stop now. I will say thank you for watching. You know, like, subscribe if you like the video, and see you on the next one. Bye. Probably see you on a live stream, yeah, because we have a lot of, laptop from Joblots. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members-only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.